Congratulations, you've reached the end of the first week of the MOOC on concurrent programming in Erlang. Well done. You've been engaging very well with each other on the comment threads. I've been pleased to see that, and I've been pleased to see people making progress with the exercises. Just a few things came up in the discussions which I thought I'd like to talk through with you. First of all, on step 1.3, talking about processes and messages, there's a question: what is a thread? Well, the idea is that a thread, for example, an operating system thread or a thread in something like the JVM, it's a piece of program execution that shares the memory with all the other threads that are running. So if you have a number of threads running concurrently, they can clobber the memory at the same time. And this can mean there can be contention for memory, but it can also mean that things can become inconsistent between different threads. One of the reasons you've perhaps heard people talk about immutable data structures, that is, data structures that don't change. Instead of changing a data structure, you build a new version of that data structure. This allows for consistency between different threads. The view that two threads have of a data structure doesn't change. Now, the nice thing about the Erlang model in the Erlang virtual machine, is that processes, unlike threads, don't share memory. So there's a whole class of problems are just eliminated. There isn't a question of different processes writing on the same piece of memory and getting an inconsistent view of the world. So that's built into the design of Erlang, whereas it's not built into the design of many other languages. I mean, Erlang is the premier, it's the beacon language for message passing, process-based concurrency. And that's indeed why we've built this MOOC, to show you this paradigm for computation and how this can be used to do practical problem solving. Okay, getting into the nitty-gritty a bit more, because message passing in Erlang is asynchronous, it's not necessary for the sender and the receiver to synchronize on sending a message. We need some sort of mailbox concept, just as the postman or postwoman delivers a letter to our mailbox. We don't have to be there to receive the letter from them. The letter sits in the mailbox, and we open the mailbox or look on our doormat, and we see that there's letters there, and then we can process them. In exactly the same way in Erlang, there is a mailbox for each process, and that's where messages get delivered. And then we process them by the receive construct. Two things come out of this, and I was very pleased Anton spotted this on step 1.7 when we first started talking about the mailbox. There's a potential problem in that your mailbox can get full of junk mail. You can get that at home. You get a pile of things on the mat, none of which you're interested in. You just leave them there. Now, if that happens for long enough, it becomes difficult to process the messages, the messages you're interested in that are coming in. And exactly the same in Erlang. So it can be a problem, and it's a problem that is typically seen, because it doesn't manifest as an error, it's seen as a degradation in performance of a system. And talking to Francesco Cesarini, who runs Erlang Solutions, this is something that he has experienced and his colleagues have experienced in looking at real live Erlang systems. It's one of the ways that Erlang systems can go wrong. Okay, but there are ways. I mean, once you see that, you need to modify your program or modify the inputs, the messages, in such a way as to avoid that. The final thing in the assignment and discussion about working with the mailbox, which is step 1.8, I asked you, was there a difference between, as it were, matching a message with a variable and then doing a case switch on that variable, or doing the matching different messages at the receive statement? Now, if you match a message with a variable in a receive statement, that will match the first message in the mailbox. If you have a set of patterns in a receive statement and you're trying to process that, that will match the first message in the mailbox that matches one of those patterns. And that may not be the first message in the mailbox. However, if the last of your patterns is a wildcard or it's a variable, then that receive will also match the first message in the mailbox. And so there won't be any difference in behavior. Apologies if there was any confusion about that. It was just to get you to think along those lines. Okay, what we've covered this week is how programs work when they're working properly. We've understood mailboxes, we've understood message passing, we've understood how we process messages. What we're going to look at next week is what to do when things fail. We've talked in this MOOC and in the functional MOOC that preceded it about the Erlang let it fail philosophy. Next week we're going to explore what that means in detail. So I look forward to talking to you in a week's time. That's it from me. Okay, see you next week.